combination of handwritten digits and letters. We would be starting with the last phase of our 2-day conference. The first paper to be presented would be in online mode. Each participant would be allotted 10 minutes to explain their presentation. At the end of 7 to 7.5 minutes, an alert buzzer would be played to remind you about the time limit. The paper title for this paper would be Bidirectional LSTM with Character and Dependency Embedding Based Approach for Biomolecular Event Trigger Extraction. So, are you ready?
Yes.
So, could you please share your
May I continue?
Yes, sir.
Okay, just a minute. Is it visible?
Yes, sir, it's visible. Could you please put it in slideshow mode?
Yes.
Yes, sir.
Okay. Good morning, everybody. Sorry. Good afternoon, everybody. So today I am going to present a paper on bidirectional LSTM with character and dependency embedding best approach for biomolecular event trigger extraction. So this is the outline of my today's presentation. First, let me define the problem that I have been interested to solve. It is on extracting biomolecular events from text. Okay, this is the type of task which is related with natural language processing, and in internet, huge amount of data there. So, and the articles related with medical domain, it is published in internet in PubMed and PubMed Center. So this the two databases which contains huge number of resources in terms of articles in the domain of biomedical. So from that huge amount of data, we try to extract the most useful information in the format of event. And bio-event is described as a change on the state of biomolecules. And this biomolecules are nothing but these are basically proteins, genes. And the actions which are performed on this type of molecules are normally called the bio-event. Different types are there for bio-events like phosphorylation, transcription. So these are different types which are defined in the data set for this. I'm coming to the discussion of that. And the major tasks involved is the identification of triggers words in the format of event trigger, and then classifying the event and then argument detection. So in this task, actually, I focused on identification of event triggers. There are mainly three types of triggers. One is the simple, which are some gene expression, transcription, proteins, phosphorylation. So these are different types, event trigger types, which are classified as simple category. And binding type is another type which actually is responsible as a binding of genes and proteins. So, and this is little bit complex, and much more complex type is the regulation, positive regulation, negative regulation, and each of these event types have been associated with their arguments, and the arguments are basically gene and gene products. If we consider one example for this task, like in this study, we hypothesized that the phosphorylation of TRAP2 inhibits the binding to CD40 cytoplasmic domain. So if we consider this example sentence, then we will find the trigger words the phosphorylation binding inhibits So these are the trigger words, which are basically the main word of event expression. And the types are simple type is the phosphorylation is one simple type, and binding, the binding is one event is there, the binding and regulation. And each of these also may have arguments, like the trap 2 is the one argument. For binding type, trap 2, CD40, these are the arguments for binding type event. And for negative regulation, actually this negative regulation is the complex, which arguments are actually the other events. So this is very difficult to identify this complex type of events. So we try to extract this event triggers which happens in the text of biomedical literature, and we consider each sentence one by one, and from that sentence we try to find out the most useful information, which is nothing but that event trigger. So I already mentioned that the two main databases are these, which contains the article either in abstract format or in full article full text format. PubMed is one important database which contains the database related to the biomedical domain, and the PubMed Central. And this PubMed Central contains the full text biomedical data in the format of journal literature. And currently, it has been said that the PubMed has over 35 million entries related entries means in the format of article in medical literature. And there are different many challenges to extract the most useful information in the format of biomedical event. The challenges are the trigger words that we are going to identify from text data. It is not a single word, multiple, it may span up to 6 words. So it may be one word, 2 words, 3 words, up to 6 words. So it is little bit difficult to extract with one biomedical event trigger which spans over 6 words. And also another challenge is there, actually there's ambiguity. It has been said that one trigger word, a same trigger word can act as different event type in different sentence. So that is the ambiguity, and so for that we can apply the Watson's disambiguation to solve this problem. And this is one example data in the format of table I have mentioned over here. Just like if you consider a company, this acts as positive regulation one time, but as regulation type as 2 times in the whole data set. Activation at one time occurs a gene expression type, but also it occurs 286 times as positive regulation. So our objective is to identify these trigger words from the biomedical literature, which is the main information of biomedical event. And for this work, we consider bidirectional LSTM, but basic LSTM is used to design the network. And in the basic LSTM, actually 3 types of gates are used: input gate, output gate, and forget gate. So input gate is responsible to forget some information, is to what information will be updated. On forget gate, this gate actually is used to forget some information. So which will be which information will be first, and some information needs to be forward, some information needs to be updated. So these things happens in LSTM cell, and it is basically one recurrent neural network where cell state and unit states are maintained and these are updated when the words of a sentence are processed, means processed through the network. And in this work, we have used mainly 3 types of embeddings. So embedding, actually, it is one popular method in natural language processing to convert actually the sparse representation of words into dense representation. And there are many drawbacks to handle it, to work with sparse representation, like the one common technique that is used to encode the words of a sentence is in terms of one-hot encoding. The TF-IDF type of detail. In one-hot encoding, we know that every word is represented by a vector of 1 and 0, where the one value will be 1 for the particular word and the other values will be 0. Actually, if we consider a data set with a dictionary of words, maybe 1 lakhs words. So for that, the size of each word will be represent in terms of a feature vector. It's
Sir?
going to be 1 lakhs.
Excuse me,
So
sir.
this is very difficult. Yes.
So you have exceeded
Hello?
8 minutes and you only have 2 minutes to sum up your presentation.
Okay. So this word embeddings and so this is the limitation to work on this. Actually, embedding is used, which converts the sparse representation into dense representation. And for this purpose, we considered we actually merge three types of embedding techniques. One is the word embedding, and character embedding. Word embedding is popularly used. We have used extra character embedding. Along with that is the new thing in this world, that the dependency embedding, that the embedding of dependency relation. If we use these three types of embedding, it has been seen that during learning through the network, it gets more contextual information. And this is the dependency. Actually, this is the dependency parser is used, and from this we extract actually the information for dependency embedding. And for every word, if you consider one example sentence, we actually find out a sequence of dependency relations from this dependency graph, and we identify a sequence of dependency relations, and from this we find out one dictionary of different dependency relations, and then we embed that information. And this is actually the architecture. These are the words of, if you consider one example sentence, the words will be put in the network, and for every word we identify word embedding, character embedding, dependency embedding. Then we merge all these three embeddings. So this is the layer which will merge all these embeddings. Then we use the bidirectional LSTM, and ultimately we find out the output from this layer. Where in the output layer we consider the submax. And these are the experimental setup for that. For the size of word embedding, character embedding, and dropout is also used in this network. Dropout value is 0.3. Batch size has been considered as 4, and optimization purpose we use the Adam algorithm, and learning rate is 0.001. And from the experimental result, here we have seen, means if you follow the table, you find the result. Individually for each event type, we have shown the result, and also the overall result has been shown. And ultimately, if you follow the result, if you consider the three embedding technique, then overall result in terms of X-score value has been 73.74. So if you consider the analysis with word embedding, the X-score value is 63.83. Word embedding plus character embedding, it is 67.04. And if you merge all the three embedding, the word embedding, dependency embedding, and character embedding, then it shows the 73.74%. While we find that it is the increase of 10% from using only word embedding. So in comparison, these three different approaches, we have seen the word embedding, character embedding, and dependency embedding. This technique has improved the result a little. Okay. So from this result, it has been seen that there is a very good impact of dependency embedding, and with the use of dependency embedding, result has improved. And in future, we would like to apply the hyperparameter tuning technique, which may improve the performance of the model. So this is all about our task, which is presented over here. So thanks. So any question?
So my question is, So you told about regulation. Am I
Okay,
right? Regulation.
yes,
So what are positive and negative regulations which you have used?
yes. Regulation actually it is one regulatory type event, and in regular it actually regulates the other types of events. If you consider here we have mentioned three types of events are there: simple, binding, and complex. So bindings are the regulatory event. So the regulatory event, it can be the simple regulation, it can be positive type regulation, and the negative regulation. The positive type regulation means where the event where it is the impact of that event is in positive sense. Means it is not like that is the binding part has been increased like, and it is the positive the word something like that verb that is used is in most of the cases it is something like that increase word.
Is it impacting embedding also which you have used?
Individually, if I follow the result, then and positive regulation, that means that is the regulator, and this is the positive regulation. And considering the word embedding, it is 62.31, whereas the in the other it has slightly increased 64.89. And using this technique, that is the word embedding, dependency embedding, it is a 71.03. So individually also it is present. It is a 73.08 when you consider word embedding, character embedding, and dependency embedding.
I have
So
one.
as overall it is increasing, also if we talk about the individual event type, then also we have seen in most of the cases the result has increased.
I have one question. In this experiment, which dataset has been used and in which language, and what is the size of the dataset?
In data set, actually, we have, there are total 963 total articles have been considered, 963, and the data set has been considered as the bioenergy GNI event extraction. Okay, it is available in NACTEM.
So it is not an,
So
any
from that-
standard dataset.
Yes, it is.
It is not any. It is not an standard dataset, right?
Yes, yes, it is a standard data set.
Do you have the name of the dataset?
It is the bioenergy ST.
Okay, and it is,
Hyphen GE.
okay,
GNI
and
event extraction.
in which language it is?
Actually, the whole experiment has been done in Python.
Language means.
So, it actually the library that has been used is Keras and TensorFlow in the backend.
I'm talking about the natural language. In which natural language it is?
It is the article is purely in English natural language.
Okay, okay.
Do we have any
Because there are many, so we have worked on only English here.
It should be mentioned in the slides because we are
Yes,
considered.
yes, yes.
Yes.
Do we have any more questions? No, thanks. Thank you, sir.
Okay, thank you all.
So you can now leave the meeting.
Okay, thank you. Okay, may I leave now?
Yes, sir.
Okay.
Moving on to our first offline paper for this session, I would like to invite the presenter for the paper titled Application of GANs for Generation of Handwritten Digits and Letters. So good afternoon everyone. I am Dia Mandal and my co-presenter Chris Calvin Demta is here with me, and our other co-author is Dr. Vandana Bhattacharjee. Our paper is on application of GANs for generation of handwritten digits and letters. These are the contents of the presentation. Objective: Our objective is to explore GANs for handwritten digit and character generation and image-to-image translation. So we implemented the Banana GANs on MNIST dataset and DC GANs, which is deep convolutional GANs, on eMNIST dataset, and evaluate the GAN performance, track learning progress, and optimize it. Highlight insights into GAN capabilities and generative tasks. Motivation. So since the birth of ChatGPT, we have been very interested in the field of generative algorithms. So from that, we started working on music generation, and then further we explored image generation. So now we are exploring GANs, the application of GANs. So we are harnessing GANs to augment handwritten and pictorial datasets, enriching diversity for robust model training. Utilize GANs for precise style transfer and adaptation in handwriting and image translation generation. Investigate GANs to push the boundaries of generative modeling in handwriting and image translation content. Contribute to better character and target picture recognition by refining models with diverse GAN-generated datasets. So the background of a generative adversarial network is GAN consists of mainly two parts, a generator and a discriminator. The generator, what it basically does is creates fake data, and what the discriminator does is it distinguishes between real and fake data. So what the adversarial methods mean over here is the discriminator and the generator are trying to compete against each other and trying to win over each other. So ultimately what happens in our model is the generator wins by producing images that are realistic looking enough so that the discriminator cannot distinguish between the images provided in the real dataset and the images generated by the GAN. So this is the typical architecture of a GAN. So what we can see here is the generator receives a latent input space or a random input seed, and from that it generates fake data, and this fake data along with the real samples from the real dataset are fed into the discriminator model, which gives feedback back to the generator and predicts whether the image generated is real or not, and provides this feedback back to the generator, and from this and then the generator again works on the feedback and produces more fake images. Methodology for handwriting digit generation. So what we have used is we have used Manila generative adversarial networks. So what the generator model does is it captures the data distribution, and the discriminator model estimates the sample probability from the data. The generator starts with a latent space, a completely noisy image. This image goes to the generator model and it tries to work with the image to produce a similar target image. As we can see in the methodology for the generator model, this is a 100x1 input space, random input seed provided to the generator model, which is reshaped into a 4x4x3 layer and reshaped by using dense layers to 16x16x256, and again reshaped back to 32x32x512 and reshaped to 64x64x1024, which is reshaped back to 28x28x1, which is the original resolution of the image, dimension of the image provided in the real dataset. Similarly, what happens to the discriminator model is it checks the image generated by the generator model whether the image is similar to the target image or not. The aim of the training is to realize a game between the generator and the discriminator, and the game's goal is to render the discriminator model incapable of determining if the generative model's output is accurate. So as we can see in the methodology, the discriminator model receives an original resolution of the image 64x64x1024, and we provide convolutional layers to reshape it to 32x32x512, and then again provide convolutional layers to reshape it into 16x16x256, which reshapes back to 0 or 1, with 1 being a real image and 0 being a fake image. So any value that is above 0.5 will be predicted as a real image. So if the generator model produces an image which is resulting in a value that is greater than 0.5, then it would be considered as a real image by the discriminator model. Similarly, this is the methodology for the handwriting letter generation part. So we have used deep convolutional generative adversarial networks, which use batch normalization and transposed convolutional layers to stabilize the process. So what happens is this model is the generator generates some noise vector to emulate the English alphabet. The generator model tries to learn from the dataset and produce similar looking images. The generator model tries to reduce the loss between the discriminator model and itself. So as we can see in the methodology, for the generator model, we provide a 50 cross 1 random input seed and reshape it into 7 cross 7 cross 32, and then again provide fully studied convolutional layers to reshape it to 32 cross 32 cross 64, and then reshape it to 42 cross 42 cross 128, and then reshape it to 64 cross 64 cross 256, and again reshape it to 64 cross 64 cross 512, which is the desired resolution for our image. Similarly, in the discriminator model, what happens is it compares the generated image with the target vector. If the discriminator model finds the image generated similar to the target image, it returns a positive value. And if the discriminator model finds the image generated to be better than the target image gets replaced with the generated image. So as we can see in the discriminator model, it is provided with the original resolution of the image 64 cross 64 cross 512, which we provide convolutional layers to reshape it to 32 cross 32 cross 256, and again reshape it to 16 cross 16 cross 128, and reshape it to 8 cross 8 cross 64, and then reshape it to 1 or 0, with 1 being the real image and 0 being a fake image. Tools and techniques used: we have used Python as a programming language, Keras is an interface for neural networks for the digit generation part, Matplotlib for plotting the graphs, NumPy for using mathematical functions, PyTorch is an interface for neural networks in the letter generation part. Techniques used: we have used vanilla GANs for digit generation, we have used DC GANs for letter generation, and CNNs for finding image patterns in the letter generation part. Results and discussion: these are the digits generated after 0 iterations. We can see it is completely noisy and we cannot make out any digits from it. But these are the digits generated after 9,000 iterations. We can clearly make out most of the digits generated by the AI. These are the letters generated after 0 iterations. This is completely noisy and we cannot make much sense of it. But these are these are the letters generated after 5,000 iterations. So these can be quite clearly made out. We can quite clearly make out most of these letters. And this is the loss graph for the generator and the discriminator loss. The loss values of the generator and discriminator are plotted for vanilla GANs for digit generation. We can see that the discriminator loss gradually increases to around 0.8, which is shown in the green line, which is shown with the green line, and it stays stable around the value during the iteration. But the generator loss shows an unyielding pattern of ups and downs during its iteration, but towards the end it becomes stable and maintains a consistent difference between the discriminator and itself. For DC GANs, for letter generation part, this is the discriminator versus generator loss function graph plotted. We can see that the discriminator loss constantly stays below 0 at all times during its iteration. The generated loss does not stay consistent as it jumps between 36 and 0, but towards the end of the iterations, it normalizes itself with contrast to the discriminator and maintains a consistent difference. As we can see, after between 150 and 175 epochs, it's getting kind of stable. Conclusion and future work: we have successfully been able to generate handwritten digits and letters using GANs. We further wish to perform generation of digits and letters with other variants of GANs and compare the results. Like, we have done the literature review and we have seen the letters and digits generated for using CNNs and other variants of GANs, but these are the variants that are most suitable as found in the literature review. But we further wish to develop, wish to use other variants of GANs such as conditional GANs or DC GANs for digit generation as well. And we further wish to develop a general handwriting generation system. These are just for letters and digits. We further wish to develop a handwriting generation system capable of producing realistic looking handwriting. And we wish to implement image-to-image translation tasks, such as sometimes we write 1 and 7 in quite a similar manner in handwriting, right? So we cannot make out, especially in the doctor's prescriptions, we cannot recognize some letters or digits written by the doctor. So what we can do is we can implement the GAN and check whether the digits generated or the letters generated are according to the label or not. And we further wish to transform one form of clothing apparel into another to make it easier for online shopping sites to display different clothing products. So this is our presentation. Thank you. Any questions?
I have two questions. Can you go to the generator model part?
Uh, this part?
Yes. Now in each step you are resizing it, reshaping it, right?
Yes.
So the data size of data is increasing.
Yes.
So how you are increasing that? Because reshaping doesn't mean that it will increase the volume of the data.
We are not increasing the volume of the data, we are increasing the resolution of the data.
Yes. How?
We are especially for DC GANs, what we are doing is we are providing transpose convolutional layers, and instead of what we originally do in CNNs, that is max pooling or average pooling, we are using convolutional and deconvolutional layers to reshape it, or I mean increase or decrease the resolution of this image.
Okay. So you are using padding or something like that.
Yes.
So you should mention that was the question. How you are doing that? How you are increasing the resolution? The next question is how much computational resource you require to train this system?
So for this system, we just used our own laptops. We did not use any high power computer or anything like that. We just used our own systems, and it took quite a while to train. For the digit generation part, it did not take more than an hour to train, but for the letter generation, it took half a day almost. And the laptop that we used was Mac OS MacBook Pro.
Okay. Thank you.
Moving on to the next presentation for the day. The presenter for the paper title, A Comparative Study on Machine Learning Approaches for Diagnosis of Thyroid Disease, shall now present.
Good afternoon to all. My name is Vaishnavi, and my paper topic is a comparative study on machine learning approaches for diagnosis of thyroid disease. I am pursuing PhD from ICMIA, and this paper is co-authored by Dr. Ritesh Jha sir and Dr. Shiva Mitra ma'am. Now these are the paper of contents of my presentation. Now, what is machine learning? Machine learning is a subset of artificial intelligence. It enables computer to learn automatically from past data. Machine learning uses various algorithms to process data, identify hidden patterns, forecast result, and improve performance. Three types of machine learning are supervised machine learning, unsupervised machine learning, and reinforcement learning. Next, application of machine learning include medical diagnosis, image recognition, speech recognition, automatic language translation, social media platform, stock market analysis, and weather forecast. These are the literature survey of my paper. Machine learning algorithm support vector learning. It is a type of supervised learning. It is used in machine learning to solve classification and regression tasks. It classifies the elements of a data set into two groups. First one, circle class, and the second one is quadrilateral class. The aim of SVM algorithm is to find the best possible line or decision boundary that separates the data points of different data classes. Next, k-nearest neighbor. It is a simple machine learning algorithm. It is used for both classification and regression tasks. When a new unlabeled data point is given to the algorithm, k then identifies the nearest neighbors to that point based on the similarity of the features. Next, decision tree. A decision tree is a tree-like model consisting of nodes. It is used in machine learning for making decisions. Decision tree is a type of supervised learning algorithm. It is used for both classification and regression tasks. In this diagram, the data points represent age, gender, symptoms, etc. Based on these attributes, the system gives a medical prescription in figure 3. If the patient age is less than 20, then prescription P1 is followed. If greater than 20, then decide gender. If male, then prescription P2 is followed. If female, then test, and according to this test, different prescriptions are suggested. Next, bias. It is a supervised learning algorithm. It is used to solving classification problem. It is mainly used in text classification that includes a high-dimensional training dataset. Machine learning used for diagnosis of disease. Machine learning play a significant role in the diagnosis of disease. It enhances the diagnostic process, early detection and treatment plans to individual patients. Machine learning is disease diagnosis involves step 1 collecting patient data, step 2 training the model to recognize pattern, step 3 classify pattern based on these patterns, and step 4 providing valuable insights for early detection and personalized treatment. Now, thyroid disease. Thyroid disease affects thyroid gland. It is a small butterfly-shaped structure that is situated in front of the neck. In India, 42 million people suffer in thyroid disease. The thyroid gland produces hormone T3 and T4. T4 normal range in adult 5 to 12 microgram per deciliter, and in T3 hormone normal range in adult 8 to 2 to 20 nanogram per deciliter. These hormones play a crucial role in regulating the body metabolism, energy, and other essential functions. When the thyroid gland does not function properly, it can lead to overproduction of these hormones, causing various health problems. Next, symptoms. The symptoms of thyroid disease can be divided into two groups. First, those related to having too much thyroid hormones, hyperthyroidism, and second was those related to having too little thyroid hormones, hypothyroidism. Symptoms of an overactive thyroid include weight loss, increased heart rate, anxiety and nervousness, heat intolerance, excessive sweating, and rapid heartbeat. And symptoms of an underactive thyroid include weight gain, increased heart rate, anxiety and nervousness, dry skin, constipation, muscle weakness, joint pain, and depression. These are the comparative study of my paper. Here, x-axis represents the reference of that paper and y-axis represents the accuracy in percentage. Now, conclusion. The current study seeks to develop an accurate and suitable method of predicting thyroid disease. Here, various algorithms apply in machine learning, and finally, we find out the NAV batch has 100% accuracy, which is the highest. These are the references. Thank you. Any question?
What data set did you use in the research?
Ma'am, these data set collected from various, including in.
Go to the graph which you have plotted, that slide.
These are the data set description of different papers we collected. Thank you.
The next and last paper for today's session, as well as the final day of this conference, our concluding paper is under the title An End-to-End Deep Learning Based Continuous Speech Recognition in Kannada Language. Good afternoon, everyone. Myself, Ishika Singh, a student of BIT Ladpur. The title of my paper is An End-to-End Deep Learning Based Continuous Speech Recognition in Kannada, co-authored by Astha Kumari, Sai Aditi Verma, Aloke Charles Topo, Vandana Bhattacharjee, and Shubhajit Paul. These are the outlines of my presentation. Proceeding to the introduction to speech recognition. What is speech recognition? Speech recognition is a process of converting spoken words into text. And why we do speech recognition? The speech recognition enables the conversion of spoken words into text to facilitate and accessibility, the automation, and to bridge a natural language interaction between humans and technology. There are the three types of speech recognition: isolated, connected, continuous. In isolated, we deal with the transcribing the individual spoken words or short phrases uttered in isolation. In connected speech recognition, we transcribe the continuous speech considering the flow of context. Now, moving to continuous speech recognition. It refers to the process of transcribing the understanding and interrupted flowing speech, capturing the natural flow and sequence of the spoken words. About Kannada. Kannada is a Dravidian language, covers about 3.61% of total speaking population of country, as mentioned in Census 2011. It uses a non-cursive script of characters. According to the Kannada grammar, it consists of 12 vowels, that is Swagalus, and 33 consonants, that is Vyanjanalus. Vowels are represented using different symbols called diacritics. The Kannada consonants are formed by the different combination of 21 distinct phones, whereas vowels are formed by combining 8 distinct phones. The motivation for developing our automatic speech recognition system. We developed this system for enhance the accuracy and efficiency of transcribing the spoken words and spoken words to convert into the text and maintain the and overcome the bridge between human and the technology. ASR has demonstrated its utility in education, healthcare, and industrial support and automation technology. Choosing Kannada as an ASR system can be efficiently used to provide the technical support to a native business and preserves the cultural heritage through digitalization, promote advanced learning and user-friendly technical and support in Kannada language as it is a mother tongue or preferred language for a communication. These are the related works in other different languages. Like in Punjabi, Jyoti Guglani has introduced an ASR system for deep neural networks using Kaldi toolkit with a word error rate of 64.25%. Whereas in Malayalam, a speech-independent connected digit recognizer for Malayalam language was developed by Korean Ital using PLP and HMM and Butterware algorithm, achieving an accuracy of 99.5%. Moving on to the next language, that is Tamil. ASR in Tamil languages for isolated words were accomplished by Bimal Ital using Spinix 4 and HMM-based speech recognition framework. This is our proposed baseline model. In this baseline model, we have taken the main spectrogram as our input and pass it through the three different deep learning technique methods, that is NCNN layer, BiGRU layer, and fully connected layer with softmax, and finally giving the output as a generated transcript. The data set we have used ICMIA Kannada speech corpus provided by Medical Intelligence and Language Engineering Lab, and it is easily available on OpenSLR. So the speech data and the transcript data specifications are: the speech data is recorded in .wave format with a bitrate of 16 beats per second and sample rate of 16 kilohertz in a mono channel, whereas our text transcript data was stored in .txt format in Kannada languages with a UTF-8 encoding. The dataset preprocessing. We have preprocessed our transcript, the TXT files containing all the continuous speech transcripts were cleaned by removing all these special characters and symbols, and punctuations were eliminated by preprocessing it. The diacritics or the matras in the transcript were replaced with the vowels character having this similar phonetic sound. Audio preprocessing. The recorded speech was stored in .wave form. We first converted that waveform into time domain to frequency domain by applying first Fourier transform method to decompose the signals into frequency components. The next step, after the spectrogram was obtained, we applied logarithmically scaling to obtain a male scale spectrogram. The speech audio signal is first converted from time domain frequency by applying fast Fourier transform. In the next step, the spectrogram was obtained. Spectrogram is now logarithmically scaled to generate male scale spectrogram as output. Now, this male scale spectrogram will serve as an input for a baseline model. CNN. When we serve a male spectrogram and as an input for a baseline model, it passes through the CNN layer. The CNN layer analyzes the visual features, and it generally used for image analysis and computer vision, as it imitates the visual processing of function of the brain. After passing through CNN, it is passed with BiGRU layer. BiGRU layer is typically used for time series analysis, and it captures the both past and future frame correlations. Finally, the output is passed to the fully connected layer with softmax function. It is a mathematically logistic function which covers a vector number into probability distribution over a number of classes. Softmax layer calculates the probabilities of the output characters with higher probabilities of the most likelihood of the occurrence of the characters in the sentence. These are the result. We have taken two models with different configuration. The first model used two CNN layers with 128 filters and 3 layers of BiGRU containing 512 units. The learning rate which we have used is 1E-4 with a batch size of 30 and Adam W optimizer. Whereas in model 2, we have used two CNN layers with 128 filters and each with 4 layers of BiGRU containing 512 units. Here we have changed the learning rate from 1E-4 to 1E-5 with a batch size of 30 and an Adam W optimizer. In model 1, we have observed that a character error rate of 23.47 was observed, whereas in model 2, we have observed a character error rate of 18.62. Moving on to our conclusion and the future scope, the end-to-end continuous speech recognition model for Kannada was implemented using two different configurations. We have observed that the model exhibited a gradual learning pace up to 8th epoch. After the 8th, the drastic increase in the learning pace with decreasing character error rate was observed. So the future scope is the experiment were conducted with the use of language model, without the use of language model, and better accuracy can be achieved by implementing a language model or using transfer learning method to create a multilingual model for continuous speech recognition in Indian languages. Other references?
Did you create your own CNN model or did you take a pre-trained one? Your own. पाइथन में आपने रन किया था गाइड के साथ. Good work.
With this, we come to the end of our 2-day-long international conference on machine intelligence with applications. I thank our session chair, Dr. Amrita Priyam ma'am, for successfully completing the procedures for this session. Now, since all our sessions have been completed very successfully, we would like to proceed for the valedictory session. I may request 5 minutes for the arrangements. हम लोग बाहर से बैठ कर इधर करना